All right, how's it going, guys? I'm re-recording this video since I forgot to record it before, but I only have really 3 problems to go over since everything else was covered in the previous video, the quiz one. So make sure you go over that. So if you want my opinion of what you should study for the test tomorrow or whenever you're watching this, I guess is that I really would watch the video if you need extra help. So what the video for the quiz review is a great thing to study. This video, obviously, the quiz is a very good resource to study too, because it's over the same material, 6.1, 6.2. It was on the quiz. The test is over 6.1, 6.2. So there's it's basically the whole thing is a huge overlap. So definitely study the quiz, and also the review is a good thing to study for the test. All right, so let's go ahead and get started. For 31, I need to write the equation of a polynomial function of degree 4 that intercepts only at 3, 0, negative 2, 0, and 0, 12. And I'm told that as the x values increase without bound, the f of x values decrease without bound, and also the absolute value of the leading coefficient is 1/2. So anytime I have these problems where I'm not really sure what's happening, I'm always going to draw a picture. Because you start drawing a picture, you can kind of see visually exactly everything that's happening all at once. So a few things I'm told is that I have a degree of 4. These are my x-intercepts. And I'm also told that when x values increase without bound, f of x values decrease without bound, and the leading coefficient is 1/2, or the absolute value of it is 1/2. So that tells me the absolute value of A, or really A has to be the absolute value of 1/2. And if I was to draw a picture, and I draw my x-intercepts, so I have negative 2, 3, and a y-intercept of 12. These are my x-intercepts, and at the same time, I'm told that as the x values increase without bound, the f of x values decrease without bound, or in other words, as x is going to infinity, y's have to go to negative. That tells me that I have to end going this way. So at 3, I have to go down that way, since if I don't, I'm not going to have that end behavior that I'm told I have to have. And also because of that, I know that my starting position or my starting end behavior, or really the end behavior on the other side, has to be down this way. And I know that because it's an even degree polynomial. And if it's an even degree polynomial, you have to start and end going the same way. So the only way this will work out now to make sure I hit this 0, 12 is if I kind of loop and hit it that way, right? So that means since I have a degree of 4 and I'm going through both these points, I'm kind of going straight through them. That means the only way I can distribute my degree of 4 is if my exponents are 3 and 1 or 1 and 3. Those are the 2 possible ways for me to distribute my degree of 4, so that I can go through those points and I'm not tangent to it. I'm not bouncing off those x-intercepts, so they cannot be even powers. So it can either be 1 or 3 for both. So from here, what I'm going to do is I'm going to make my cases to kind of figure out, well, what is my actual function. So f of x has to equal some a, and actually we can actually go back to the a right now before we leave this problem. Because I'm opening down and my end behaviors are both going down to negative infinities, I know a has to be negative 1/2. Right? If you remember your little chart, so if you have degree on the top, I'm gonna put L dot C for leading coefficient. If you're even with a positive leading coefficient, your end behavior is like y equals x squared. If it's odd with a positive leading coefficient, it's like y equals x. If it's negative, it's going to look like this. If it's odd, it'll look like that, right? And since where I'm at right here is the bottom left, I know that I have a negative leading coefficient with an even degree, which is 4. So that's why I know that a has to be negative 1/2. It can't be positive. And the reason I'm going back to that right now is because I have to plug in my a value when I need to solve for what my exponents are going to be, right? So my 2 options are going to be x plus 2x minus 3, my x-intercepts, and I can either have a degree of 3 and a degree of 1, or I could have the opposite, which I'm going to do in blue. It could be x plus 2 to the first power and x minus 3 to the third power. These are my 2 options. It can be either the green one or the blue one. I'm not sure which one. So once you have all your options listed out, what you want to do is you want to go ahead and plug in a point on the graph that you know exists to see which one actually works. In this case, it's going to be 0, 12. So just plug in 0, 12 into both these equations and kind of see which one works. So for the first one, if I plug in 0, 12, 12 equals negative 1/2. 0 plus 2 is 2, all cubed. 0 minus 3 is negative 3. So 12 equals negative 1/2. That's 8 times negative 3 is negative 24. So what you end up getting is 12 equals 12. Negative 1/2 times negative 24 is a positive 12. So this actually works. That's why this is going to be your answer. But I'm going to go ahead and solve out the other side too. So I want you guys to see what's going to happen if it doesn't work out. So I'll plug in the same point, 0, 12. So 12 will equal negative 1/2. 0 plus 2 is 2. 0 minus 3 is negative 3. All cubed. So what you get is 12 equals negative 1/2. Negative 3 cubed is negative 27. These cancel out, and you're left with 12 equals positive 27. That's not true. That's why the blue one isn't going to work, and your answer is going to be what's boxed in green. All right, let's go on to the next problem. So for 33, write the equation of f of x is f of 5 equals f of negative 2, which equals f of 1, which equals 0, and f of 3 equals f of 6, which equals 80, and f of x is a polynomial of degree 4. So what I'll do here is, same thing as before, I'll draw a picture, but this part right here is really complicated part. All it's really saying is that I have the points 5, 0, negative 2, 0, and 1, 0. And this part right here, f of 3 equals f of 6, which equals 80. That just tells me I have the points 380 and 680. And I'm also told I have a degree of 4. So what I'm going to do now is I know what points I have. I'm going to go ahead and just graph this function. So I have points at negative 2, at 1, and at 5. And I'm also told I have points at 380. That's going to be between 1 and 5. So like right up here. And at 680, which is to the left of 5. So I know for sure I have these points on the graph, and they all have to be on this polynomial that I have to draw. So what this tells me is that from this 5 going to the right, I have to go out this way, because if I don't, I'm not going to hit that 680, which I'm told is part of the graph. So that right away tells me what end behavior is going to be. And at the same time, I have to make sure I hit this 380 without making any other x-intercepts. That means at 5, I have to bounce, because if I go through at 5, I have to make another x-intercept to make sure I go back up and hit that 380. That's why at 5, I have to bounce off it to make sure I don't make another x-intercept. And then when I go to 1, because I only have a degree of 4, and I use 2 of those degrees on 5, 1 and negative 2, sorry, both have to have an exponent of 1, because if they don't, I'm not gonna have enough, or I'm gonna have a higher degree than I'm told I have. So that's why I have to go straight down at 1 and straight through at negative 2, because if I don't, I'm gonna have more exponents that have degrees, and I can't do that. So I'm told that the degree has to be equal. So if I go ahead and graph this, I have f of x equals some leading coefficient of a that I don't know what it is yet, but I do know my x-intercepts. I have x plus 2 from the x-intercept of negative 2, x minus 1 from the x-intercept of 1, and x minus 5 squared from the x-intercept of 5. And I know it'll be a power of 2, because like I said before, it has to bounce, because if it doesn't, I'm not going to hit both those points that I'm told is on the graph. So from here to solve for a, all you need to do is plug in any point on the graph. So you can plug in 680 or 380, it doesn't matter. I'll plug in 380. So 3 plus 2 is 5, 3 minus 1 is 2, and 3 minus 5 is negative 2 all squared. Plug in 3 for x, I'm plugging in the point 380. And then just solve for a. So a equals 5 times 2 is 10, negative 2 squared, that's 4. So you have 40a, or a is 2. So that's your a value. you just go back up here, plug in 2 for A, and that's going to be your answer. All right, so basically, you have to draw your picture, kind of see, well, what am I told? What does that mean about the picture that I'm drawing? And then from there, you can kind of figure out, well, what should my exponents be? And you can go. All right, and the last one I'm going to do is number 37. This one has a lot going on, but what I'm told is to write the equation for a polynomial of degree 6 that has 2 local minima and 3 local maxima. Intercepts at 2, 0, 5, 0, negative 3, 0, negative 1, 0, and negative 2, negative 28. And I'm also told the absolute value of the leading coefficient is 1. And I'm also told f of x is less than or equal to 0 and x is less than 0. So there's a lot of things I'm being told here. So one thing I'm being told is that the absolute value of a, or really a is the absolute value of 1. That tells me it can either be positive 1 or negative 1. I'm not really sure which one. And I'm also told I have all these x-intercepts, which I'm going to go ahead and I'm going to graph. So I go ahead and graph all these x-intercepts. I have negative 3, negative 1, 2, and 5. And I also have this point of negative 2, negative 28, which will be, let's say, right here. Between negative 1 and negative 3. And the important part here of what I'm being told is that f of x is less than or equal to 0 when x is less than or equal to 0. What that's saying is that when x is negative, so if I'm on the left side of this y-intercept, or when my x's are negative, your y's also have to be negative. That means I have to be to the left of the y-axis and below the x-axis, or in other words, I have to be inside this little green box that I'm drawing. I have to be in that bottom left quadrant, because that's the only time when x is less than 0 and y is also less than 0. So that means I have to be in this left quadrant when I'm on the left side of the graph. Or in other words, when x is negative, y has to be negative as well. So what that tells me is that my end behavior has to start from the bottom here, because if it doesn't, I'm already contradicting that statement. So I have to start from the bottom left. And when I go to that first x-intercept of negative 3, to make sure I stay inside this green box, I have to bounce off that negative 3. And I hit that negative 2, negative 28 that I know I have. And when I go back to that negative 1, I have to bounce off that one as well to make sure I stay inside that green box. And once I pass that green box, like once my x has become positive, it doesn't matter where you're going. It can go anywhere. You can be wherever it needs to be. So if I go back to the problem, I'm told I have a degree of 6. So if I look at what I have so far, I have 2 tangent points, or 2 points that are bouncing off the x-axis. So that means I'm using 2 exponents each for each of these problems, right? So I have to use an exponent of 2 or a degree of 2 for negative 3, another degree of 2 and negative 1. And then for 2 and 5, because I only have 6 degrees to use, they're kind of left with 1 and 1 each. That means I can go through 2 and 5 and I end up getting a graph that looks like that. And it does have 3 local maximums and 2 local minimums, like I'm told. So that's what the graph should look like. And then from here, all we need to do is draw it. And if I'm looking at this graph right here, I can see that I'm opening down both ways. So that tells me that A needs to be negative 1, right? I'm told A is the absolute value of 1. Well, since my end behaviors are kind of like an upside down quadratic, right? I'm starting bottom left, ending to the bottom right. That tells me my A is going to be negative, and I do have an even degree. So if I go ahead and draw or write out my polynomial equation, f of x is going to equal my leading coefficient of negative 1, since A is negative, times x plus 3 squared from the negative 3, or from the x-intercept of negative 3, x plus 1 squared from the x-intercept of negative 1, then x minus 2, x minus 5. So that's the answer to that problem. That's all the problems I'm doing, because that's really the only thing that's really left that we haven't covered that wasn't on the quiz. So really, if you want to know what to study for the quiz, study the quiz. I mean, sorry, what you want to know to study for the test, study the quiz, because there's a huge overlap between the two. Do the last video. The last video is pretty good to kind of refresh your memory on everything. This video, we have 3 extra problems that weren't on the quiz that you will see something similar to one of these problems on a test tomorrow. So make sure you know how to do these. I think there's another problem similar to this on the review. I want to make sure you do that one as well. And problems on the notes, of course, do the notes as well. That'll be helpful too. All right. Good luck on the test tomorrow.